Welcome to this guided project, Getting Started with R. My name is Olayinka and I'll be your instructor for this project. This project is for people who are interested in using R for data analysis. This project will provide a solid foundation for your exploration in the use of R programming language. In this introductory video, I will talk about first, what is R and why use R. Secondly, I will talk about an overview of the RIME platform. Thirdly, I will talk about how we can understand the R user interface called RStudio. Lastly, we will start to write basic R commands. I will teach you how to use the R programming language for data analysis. Although this project is just an introduction to R, you don't need to be a data analyst expert or a data scientist to take this project, but you should be open-minded to get the most out of this project. I'm so excited to teach you how to effectively use R for data analysis. This will be most likely the first project in a series of mastering R for data analysis. I've been using R for some years to solve some challenges and build models for machine learning. So I have good experience in introducing the concept in a beginner-friendly manner. By the end of this project, you will have a good understanding about the basic concepts that surround using R. So the question is, what is R and why use R? R is just a tool like Python, like JavaScript and the rest of them. And it is open source, it is cross-platform, that is, it cuts across different platforms. It is also a free programming language designed specifically to build statistical solutions. R is powerful. It can give you access to the CRAN repository that has over 10,000 packages with predefined functions for almost every purpose, from machine learning to survival analysis to time series analysis to different analysis. So R is powerful. Then also it stays relevant. Over the years, it has been constantly updated by users, which cuts across data scientists, statisticians, researchers, students, and it has a very beautiful community where you can always get access and help. Also, R is you can do much more with R. It can be used for to make beautiful graphs. It can be used to create custom functions, applications, a lot of other things, and it can be integrated with many other environments and platforms such as Hadoop and so on. Beautiful. So let me do a quick overview of the RIME platform. This is the RIME platform. On the right side panel, you see the one you see currently, it's my own cloud desktop. It's currently in the expanded mode. I can return it to the collapsed mode, which we'll be using mostly. And you can see I'm sliding over my cloud desktop right now. The one on the left hand side that you see is yours, and this is hands-on project. So this means that you have to watch what I am doing and follow these steps along on your own cloud desktop. If you need to pause my instruction at any time, please bring the cursor on top of my cloud desktop and click on the pause button. If I'm going too fast or too slow, you can increase or decrease the speed of my video by clicking the speed button below the pause button. R has a very beautiful user interface, just like we can see on the screen. This is called the RStudio. Throughout each task in this project, I'll show you how to maneuver R to get the desired result. Alright, let's do a quick dive in to understand the R interface. Let me go back to the expanded mode. Usually this should have four different sections. So let me reduce this, click on that part. So good. This part you see here currently is the where we write our R script. This is where you write the R code. Down here is the console where the output of whatever you write here is being returned. In this part here, we have environment. This environment stores every variable or any variable that we input. You can also see the history of all the codes you've written here, and that is for that part. For this part, you can see your files that is in your folder. Currently, we are not in the right folder. Would see that. You can see plots. You can see packages that you currently have. In addition, you can also, even though we'll be installing some other packages, you can also see help. You can also see viewer. Good. One more thing before we continue. Currently, we have a white background, which is not might not be good for people's, maybe the eyes of some people. So we would like to change the background. So I'll go to view, paint, paint layout, because we'll be using this a lot. So I go into appearance. If you click on these different themes, the third themes, you see different colors, but I prefer Cobalt, so I'll choose Cobalt, and then I can just increase the font size to say 11. I'll click on OK, and that is it. So this is better. In addition, we could just try to reduce this part here just to have more space to work. Good. So next thing is, currently we have this untitled script editor. I want to go to files because I've prepared a file for this project. So I'll go to file, and from file I'll go on to open file, and then right on my desktop I have the file getting started with R. So I'm going to just click on this. Good. So we are good to continue. Great. I think we have had a beautiful introduction to R programming. We'll stop at this point and continue in the next task. In the next task, we'll see how we can start writing basic R commands, and from there, we'll start to explore some very, very, very intuitive and basic things about R programming language. Okay, welcome back. In this task, we'll start exploring the R programming language by writing basic R commands. So the first thing we want to see is variable assignment. So assignment generally are just lines of codes that are used to store values, all right? And once you do that in R, it stores in the environment. So if I store a variable, like a value in a variable, you'll see it come up in the environment. Currently, the environment is empty. However, if I do not store a value in a variable, the output will just come out on the console here, or maybe on the plot. So let's see how we can make variable assignment in R. There are basically three ways, but there is one that is most used. I'll talk about it in a short while. So I want to assign x to equals to 1. I want to assign x equals to 1. How do I do this? I've done that. Then the next thing is I want to run this. So I press Control Enter, and you will see that will run on this. You can see that Control Enter, and then it stores here on the environment. Good. The next way I want to do variable assignment is I want to assign y to 2. This method is mostly used because many times when we use equals to, it kind of, by the time we start writing more complex as we advance, you'll see that having equals to could cause different issues, like technical issues. So this second method is usually preferred. So I want to assign y to 2. I just simply say y, then less than hyphen 2. Now it looks strange at the first sight, but I can assure you that as you move on, you will get familiar and better at this. So this is the second way of assigning variable. Control Enter, and you see that y is already assigned to 2, and you can see that y is 2, so it stores in the environment. Thirdly, this method is not used at all because it looks so difficult, So I want to assign z to 3. How do I do that? I just say I'll start with the value I want to assign, 3 hyphen greater than z. So if I Control Enter, you will see that has stored already, z equals to 3, and you see there on the environment. Beautiful. So these are the three ways to store variables, that is to assign variables, but this second method is the most used method. Let's see how to work with functions. Of course, as we move on, we're looking at a lot of functions, but the first function that every programmer learns is the print function. So we want to see how we can do print hello world in R. So I think that is so direct. So simply say print, open brackets, apostrophe, quotes, then hello world. Good. So I run this, Control Enter, we can see that it has printed hello world here. But if you come to environment, you wouldn't find it because this is not a variable. It's just you are printing something, and that's why the output here comes on the console. Next is let's perform some computation. So the same way we could perform some mathematical operations like addition, subtraction, multiplication, division. The same way we can do that in R. So we want to add 17 to 5 plus 5. Control enter, and you will see the output here on the console, right? But it will not be assigned a variable on the environment. Good. I want to add x to 5, so I can say x plus 5, control enter, and you notice that the answer is 6. If you look at this place, there is no variable assigned. Why is that 6? Because x was assigned to be 1, so 1 plus 5 is 6. You can also do, say, okay, let's move on. So okay, we want to add 15 to 5. I want to store it in a variable called y. Don't forget y is 2 here before, but let's see how we can work. So I want to say y less than hyphen, right? 15 plus 5. Control enter. Now, if you go on to this environment tab, you'll see that oh, y is now 20 as against 2 earlier. So with this y, we can do different things, all right? So I can say, for example, y minus 10, control enter. You see that the result will be 10. Say if I want to do, for example, division, I can say y divided by 2, all right? That will give me 10 also. Okay, I can also do raised to power, different operations. So y raised to power, to do raised to power in that will be double star, right? Raised to power 2. If it's just multiplication, it will be 1 star. So control enter, and we see that the result is 400, but that doesn't change the variable y, all right? But we're just using y to perform operation. Now, if we would now perform, use a square root function, which is a math function, say y equals to assigned to square root of 16. So if I run this now, let's see, control enter, you will notice that the result will change, all right? Now we'll notice that instead of 20, y is now equals to 4. So that really makes sense that whatever you assign in a variable to, you overwrite whatever the variable has been assigned to earlier. I can also find the square root of 16. So I want to just say sqrt 16. Now, if I press Ctrl Enter now, you'll notice that this does not do anything to y, right? But it just prints out on the console. So whenever you do not assign anything to like a variable, so it prints out on the console. Now lastly, we want to see how to call variables in R. So I can call my y by just saying y, just by just typing the variable and just pressing Ctrl Enter, it prints out. I can also call x, I just press x, and that way it press Ctrl Enter and it just prints out like that. Beautiful. Great job on completing the second part of this project. In this task, we learned about the R programming language and how to write basic R commands. In the next task, we'll pick it up from where we left off here, and we'll start to understand the different data types in R and how they are used. Okay, welcome back. In this task, we'll look at the different data types in R and how they are used. But before we go on, I would like to revisit the idea of variable assignment. A basic construct in programming is variable. A variable allows you to store a piece of data. It could be a number like 6 or a character like hello and so on, or several pieces of data that have common type, and you assign them to a unique name. You can then call this variable name to easily access the values that are stored within that variable. So let us get started again on variable assignment. I want to assign the variable x to 6. That's a numeric type, right? So just like we've seen, just say x less than hyphen 6, Control Enter, and that overwrites what x is earlier. Next is let's assign a variable hello that is a character type to a variable w. So let's say w hyphen, all right? Because the character, put it in quotes, control enter, and you will see that w is equals to a character. Good. Now note that R is case sensitive. So having small letter z and capital letter Z can coexist in the same R environment and they have different values. So let us see how that is. So I want to store small z in world. I want to give it I want to put the value world to it. So I just say z, small letter z is hyphen world. Now if I do control enter, this gives an error. Why? Because this is not found. So if it's word, it has to be in quotes. Please note that character is in quotes. Now if I run control enter on that, let's see, and you see it runs well, and small letter z is that. So I want to store capital letter Z as say 8. So let me put capital letter Z equals to 8. So that is stored. Next is let us try to call these variables like we've seen. So to call a variable, I can just say, I can say print z. I can say print small letter z, control enter, and it prints word, or I can just call the variable z. These two ways are used to call variables in R. So control enter, and that gives 8. All right. Good. So the next thing we want to try to do now is to add some objects together. Let's say I want to add x, which is 6, to z, right? And store it in a new variable, let's say a. So I can say a less than hyphen x plus capital letter Z because they are the same data type. All right. If I do that, I will clearly see that a is equals to 14, right? Next is I could also say, so I can also say b x plus y because they are both of the same data type. If I control enter, in fact, I can also call b here. Just type b, control enter, and you see that b not, oh, okay, I didn't assign this well. Okay, you have to be very careful. That's why the error code is there. Yeah, it's control enter, and that shows clearly. So you should be careful when you're assigning variable. Now, what do you think will be the result of this 2.4? W is a character, Z is a character. So if I do this plus this, what do you think it will be? So you can pause my video to think about this. So if I do control enter on this now, this says that error. So because they are non-numeric, because they have the same data type character, does not mean we can add them together. All right, so let's now start exploring more about different data types that we have in R. R works with numerous data types. The most common types are decimal values like 3.5, and this is called numeric. Another one is natural numbers like 3, 5, 10, and these are called integers. Then they are also, integers are also numeric. Then there is the Boolean or logical data type where you have something like true or false. All right. Then there's the text or the string that is also classified as character. We've seen that. Then there are categorical variables that are called factors. They are finite and defined set of values that can take different values. So let's say, for example, movie rating, or maybe different colors, green, blue, black, brown. Then there are other variables that can contain time data such as date, date of the week, day of the week, hour and minute, etc. Now let us consider some of these data type. Numeric will be the first one. We want to check. Don't forget we have a variable a here earlier that is 14. We did you remember we did x plus capital letter Z and we got that. So we want to check the data type of that variable a. To do that, to use this class function. So you say class, and one beautiful thing about R is that once you type something, it gives you an idea of, it just gives you an idea. So you can see it's a simple function that checks the data type. All right, so I put my bracket. I want to check the class of A, control enter, and this tells us that it is numeric. Good. Now let us have a variable, let's say num. I want to set it to 8.5, say num. So control enter. All right. If you print num, you see that 8.5. We can check the class, the data type, and that tells us numeric, like we've seen. But what if we want integers? How do we change this numeric, this decimal value to integer? So I can say int. Let me have a new variable int, and to just change it to integer, I just do as dot integer. I do not want you to be so anxious. As dot integer simply creates an object for the type integer. So what I want to just do is I want to try to put this num. All right. So if I run this now, control enter. All right. I can clearly see now that if I come to check the class of integer, all right, I can now see that it's an integer. Good. Now I have this character that I've made earlier, w is equals to hello. I can also check the class of w and it says character. Good. Now let's create a character variable from a numeric variable. So let me say car, the variable name, and I want to say put it as 1, 2, 3, 4, 5. Although this 1, 2, 3, 4, 5 are numeric, but because I've put it in quotes, it becomes a character. Now if I run this, control enter, okay, then we'll come down to check, print the character. We'll see that the class here is what? Character. And if you look at it, you see it's in quotes, that means a character. Let's go on to Boolean. So I said Boolean can actually take true or false. So let's say I have a variable log. I just save log, maybe a variable log. I want to put it as true. If I do control enter, that runs fine. Okay, so if I come over here to check the class of this variable, so let's run that. And we'll see that now the class of log is what? Logical. Good. So we've seen different data types from character, numeric, integer, log. Now log, which is logical or Boolean. Now let's see lastly factors. We want to store a movie rating and fact. So I have fact. Okay. So I want a factor data type. So I have factor. Now we use to store more than one variable, more than one value, we use this C function. So if I type C, inside this C, I can store different like different values. So maybe I have 3-star movie. The next thing is like maybe I have another 2-star movie like that. So I have just stored different movie ratings. So the only thing here is this addition of C, and we'll be looking at that more. When you want to store more than one variable, more than one value in a variable, use C function. So I want to make it factor. I just going to control enter, and if I check the class, it says factor. Good. Now if I have a lot of variable like in a factor, how do I check some levels? So for example, I want to check how many different or unique values I have. So I'll use levels to check that. Levels, I want to check the levels of the fact variable, and that tells us that there are 2-star, 3-star, 4-star, 5-star. I can go ahead and say I want to check n levels, like the number of levels. Now the number of levels here is, let's see, so there are 4 different unique values. But now one more last thing is, if you want to check, let's say the class of each of these levels, you will notice that the class of each of these levels is a character. Yeah, so each one of these, so 2-star is a character, 3-star is a character, 4-star is a character, 5-star is a character. But using this factor here now brings them all together and makes them a factor, like a categorical value. Lastly, you can check all the variable objects that you have defined in your R script by just saying ls and then a brackets opened, and that would show you all the variable that we have defined since we started working on this, and you can see all of these variables here. And okay, beautiful. You just saw the different data types in R. Great job on completing the third part of this project. In this task, we learned about the different data types in R and how they are used in R. In the next task, we'll pick it up from where we left off here and we'll start to understand vectors as a data structure in R and how to perform subsetting on vectors created. Alright, welcome back. We'll take it a step further in understanding the different data structures in R. In the last task, we looked at vectors as a data structure. In this task, we'll see matrices as a data structure in R and how to perform subsetting in on matrices created and even how to access rows and columns of a matrix. What is a matrix? A matrix is simply a sequence or collection of data elements of the same basic data type arranged in a two-dimensional array. What's a two-dimensional array like? Unlike vectors that is just one, right? So a matrix is in two dimensions, all right? So let us see how we want to create a matrix out of the mark variable. Remember the mark variable had four elements. So we want to create a matrix of two rows and two columns. From our understanding of matrix, so let me give it a name. Let's say matrix 1, right? Matrix 1. So I have to make this a matrix, all right? I will have to just type matrix. All right, so having that matrix, if you look at this, it tells us what we have to have. So in this, we have to have the data we are talking about, n rows, which is the number of rows, n columns, which is the number of columns, by rows, and the dim names. Or of course, I would talk more about each of this, but the basic thing is we have to have a data, which in this case is max. The number of rows we want two rows, and number of columns we want two columns. So let's quickly do that. Max. So matrix 1 has been created. If you look at this now, you'll notice now that this is a data, all right? It's not more a value, it's not a data. Matrix 1 is a data. Okay, so let's call it and see what it looks like. Okay, so I can also maybe clear this output a bit, say Control L. If I press Control L, it clears this console. Okay, good. So let me now do Control Enter and then to run the matrix again. So we can now see that the 14, 28, 26, 14, 26, 28, 30 is now rightly loaded to a 2 by 2 matrix. Now, one thing is that there's one more additional thing to add to this matrix, which is the by row. If you notice that this particular matrix was formed by filling the column in column wise. So we can also add a by row to make sure that it fills in row wise. All right. So it depends on what you want. What do I mean? Let me just copy that and paste it here. And let me add by row equals true. So I've changed that to by row equals true. Let me change this to matrix 2. All right. So as not to cause confusion. So Control Enter. That runs fine. Let's call the matrix 2. All right. What do you notice the difference? Now, this fills, the max as 14, 26, 28, 30. For this first one, it fills it column wise 14, 26, 28, 30. Now, for the second one, because I added by row to be true, I wanted to start filling it row wise. So it starts 14, 26 in row wise, 28, 30. I think that is clear. Now let us create an integer variable int that goes from 1 to 9. We've seen that before. So int. So I start from 1 to 9. If that runs fine. I can decide to also call the variable int, and you see, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We want to make a matrix out of this so I can have matrix 3. Matrix, so I want to have integer there, the number of columns, that's n rows first. Number of rows, I want it to be 3 rows, and the number of columns, I want it to be ncol. I want it to be tab, yeah, 3. So I want it to just fill column wise, no issues with that. So if I run Control Enter, that runs fine. All right. Now let's call the matrix 3. Okay. So we can see the matrix 3 now as field 1, 2, 3, 4, 5, 6, 7, 8, 9. Beautiful. Now let's access the second row and the second column. We've seen how to do that with vectors. Same thing applies. So I say matrix 3 square bracket. The second row, that is 2, comma, the second column. Unlike vectors is just a one-dimensional array, just like one-dimensional collection of numbers or values. So if I through Control Enter, yeah, so it gives me 5. So if I look at this here, I can clearly see that I have 5 here. 5 is on the second row, this row row wise and then column wise. All right, so I can access the second row, every element in the second row alone, by doing matrix 3 square bracket, then I put 2 and I just put a comma. What does this mean? This means that I want only the second row. So a matrix is always row by column. A row is always like horizontal, columns are vertical. So I want just the second row. If we run that, you can see we have 2, 5, 8. So this returns all the elements in the second row and all the elements in second row. All right. Now, what if I want to access the second column? That is, I want to access this 4, 5, 6 here, this one here, right? So how do I access that? I can just simply say matrix 3 square bracket, then I put a comma and 2. All right. So that's just the dynamics there. Oh, this should be matrix 3. Okay, so you have to be careful. Let's change that to matrix 3. Now in this case, as expected, we now have 4, 5, 6. Good. So that's how to just subset and slice matrices. So what if we want a sub matrix? We want the first row and the first 2 rows and the first 2 columns. So how do we do that? You can just say matrix 3. All right. So I want the first 2 rows and first 2 columns. So that will be simply matrix 3 square bracket. So this is the first 2 rows, comma, the first 2 columns. So running that clearly gives us the answer we want. Okay, beautiful. So another way to do this is, maybe I don't want the third row and the third column, like just like I have there. I can also do matrix 3 square bracket and have -3, comma, -3. I think we've seen this idea of minus, so it will not return what we have on the third row and on the third column. So if I run this, and exactly what we have. Beautiful. That was amazing. Great job on completing the fifth part of this project. In this task, we looked at matrices as a data structure in R and how we were able to see how we can access certain rows and columns of a particular matrix. In the next task, we'll see how data frames are also data structures in R, and how to also perform subsetting on data frames. All right, welcome back. In this task, we'll look at data frames as a data structure in R, just like vectors and matrices, and we'll see how to access specific rows and columns of a particular data frame. So what is a data frame? A data frame is used for storing data tables like rows and columns. It can take a list of vectors of equal length, very important, equal length. Unlike matrices, we can gather vectors from different basic data types that we have. So let's create a data frame of 2 columns from the mark variable we created, that is a numeric variable, and charvec, that is a vector variable, that is a character variable. So let's say df is the name we want to give to our data frame. Then we want to make a data frame out of it. That will be data dot frame. All right, so we want to have charvec. Okay, and max. Okay, so if I run this, control enter. Okay, that's good. But before we check the class, let us print out so we can see ABCD. So these are of equal length. Let's check the class. It says data.frame. Beautiful. So we can see that this is how to get a data frame, like a table in R. Next is one to check the structure of each variable of features in the data frame. So a variable or a feature is each column. So carvec is a feature, mark is a variable or an attribute. So I'll use these words interchangeably. To check the structure, I can just use str. So once you type something like that in R, it will give you an idea. Okay, what is str? It's used to display the internal structure of R objects. Well, how this helps is that if I have hundreds and thousands of row of columns, how do I check the structure of each of these? Do I start doing pick each of these columns one by one? But how do I do this? I just have to just do str, and that will just tell me the structure of the different features that I have. So I have carvec. The structure of carvec is a factor. The structure of max is what? A numeric value, that is a numeric data type. Then if you notice one more thing, there are four observations of two variables. That's what structure will help you to do. Another thing is you'll see this dollar sign in front of vec of each of these variables. That is, it means you can use that to specifically check a column, the data type of a column. So if I want to check, for example, the data type of a column, I can say class, which we've seen before. Let's say we want to check df. So dollar sign here means that I want the df, which is my data frame, and I want to access a particular field or a particular column or a particular attribute, say max, for example. So if I check that, I can say that it's numeric. I can allow you to do that. Check also the class for the car vec, and you will notice that it is also a factor, all right, of four levels. Next is we can also call a particular column, which we've seen before. So if I want to check the values in a particular column, I'll just simply do df dollar sign max. So this will just tell me the different values: 14, 26, 28, 30. Another way to do that is just to simply say, just like we've seen in matrices, you call the data the name of the variable. Then this comma here means that I want all the rows, but I want the first column. Okay, so if I do that, it will return the f. So it returns the first. Don't forget the first column in this case is carvec. That is why it returns the first what? Column. All right. So this is to check the different ways of accessing columns of a particular data frame. Beautiful. Now let us see how we can access a sub data frame, like the first three rows. We've seen that a lot from the beginning, so I can just say df square bracket. In fact, I can even store this in a new variable, say df1. All right. So that should not be underscore, that should be hyphen. So from the df1, the first three rows, that's 1 column 3 comma. What does this mean? It means I want all the first three rows, that's 1, 2, 3, and then I want all the columns. That's why I did not put any number after the comma. So note the difference between comma and this column. So if you need to pause my video and look at what I've done earlier, when I use comma, I want to access rows and columns, but when I use column, I want to see the multiple rows or multiple columns of a particular data frame or matrix. So we can see that if I now print out the f1 df1, okay, you will see that this returns the first three rows of the data frame df, as we should expect. So if I decide to change this to here and come over here and change this to 1, that I'm trying to say, give me the first three rows of the first column. So if I run that again, and you will see that that's what will happen. What you notice now, you see that it returns ABC, all right, just because we want just the first column. Next is I have prepared this particular data frame that takes vectors. So name is I gave it a name. Now you see where I said using equal to and this sign could be confusing. So you see where it is good to use this particular means of assignment. You can see in this particular data frame I'm using equal to so as not to make things complicated. So you get the difference now. This stores a vector of character names, Olayinka and co. Then this stores a character of integers age. This stores a character of numeric values, which are decimals. So if we just run this now, Control Enter, you can see it has run that. Let's now print the data. Let's see. We can see the three rows, they have the same length. That's why there is no error. If you check the class, that you would see data.frame, which is the data frame, because that is the class we called when we when we started creating the data frame. Now, one thing, n rows and n columns is very useful when you have a large amount of data frame of data set, like millions and thousands of rows, but you don't know how many rows are there. So you can so n rows. With that n rows, you can now check how many rows, like the number of rows we have. So running n rows and n columns shows that there are 3 rows and 4 columns as expected. Next is I've also created another data frame that adds additional 2 rows to our data frame earlier. I want to show us how to use a particular function of data frames. That's why I'm creating this for us. So I have highlighted this and control enter, and that has run fine. Good. So I want to show us how to use rbind. Rbind is row bind. For example, if I want to append or concatenate rows to a particular row, another like 2 different data frames. If I have rbind like this, all right, you would notice that if I do data, I have 2 data frames. Now one is data and the other one is data one. So if I have data, comma data one, I can decide to store that in a new variable df2, for example. So I have this df2. What this rbind does is I have data with 3 rows before, then data one now with 2 rows. So let me see. It adds its role fashion. That is, it appends it in a role fashion. Let me run this, control enter. Control enter. So you now see that the 2 names and the data I've added now is now added like in role fashion. Now we have 5 rows and 4 columns still. Now what if I want to add additional columns? I want to add the gender of these people and the last name. If you notice that the gender here I have is 5, I make sure it is 5 because they must be the same length. I can use cbind, which is just like the opposite of rbind, column bind. So cbind is column bind. If I do that, all right, you can read these details on what it means. If I want to add that, so I can have df2, okay, gender and last name. So I can decide to store this in the new variable also, say df3. So what this will do is now to add the gender and the last name colon. So I will now have 6 columns. So let me run that. Control enter, and I have that. So df3. So that clearly shows what we have. So we can see that we have now 1, 2, 3, 4, 5, 6 columns and 5 rows. Lastly, let's check the structure. Remember of data frame str of the f3. Control enter, and it will tell you the structure of this particular data frame. So we can easily see the structure, the different data types of each of the features. Great job on completing these tasks. In these tasks, we learned about data frames and how to access the different rows and columns of a particular data frame. In the next tasks, we'll learn about list as a data structure in R. Okay, welcome back. In this task, we learn about list as a data structure in R and how to perform subsetting on the list created. In simple terms, a list in R allows you to gather a variety of objects under one name, that is the name list, in an ordered manner. These objects could be matrices, vectors, data frames, even other lists. It is not even required that these objects are related to each other. Let us see how this works. Remember that we have created a vector, a matrix, a data frame earlier. Let's put all of this together in a list. So let's create a list of 4 objects, right? Let me call it lists. Okay. So in that list, I'll put list here. Good. So to show that it is a list, I want to put my car vec. All right. Then I want to put the marks of the student. Then I want to also put, say, the matrix one, different objects. They don't have to even be of the same length. And I want to put df. So let's control enter. I run that list. Let me call the list list. So that shows, if you go up here and scroll up, you see the different objects in that particular list. Now, how can we access a particular list a particular object in the list. So we have four objects here. What if I want to say I want to get the first and the second object? So I'll say list. Unlike other data structures, list will take double square brackets. So I have the first element or the first object, and it gives me the first object, which is carvec, which is a factor variable. Next, let me get a second one, list, double square bracket. I have two, control enter. It gives me the max, which is we've seen. Now I want you to pause my video and try to access the third and the fourth object in this data frame. I'm sure you agree with me that it will be list double bracket 3. Good. So that returns a matrix. List double bracket 4. That should return the data frame. Beautiful. So we can now see how to access different objects in the list. Now what if we want to call the first row of the third list object? Okay, this is not different from what you know. It will be list double square bracket. This is send me the third object like we want. Now we want the first row. So beside this, I would have another square bracket that is 1 comma. What does this mean? The same way we usually access the first row and all the columns is the same way we've done. We just have to reference the third object. So if we run this now, the third object, remember the third object is a matrix, and you can see from here we are able to access the first row of the matrix 1428. Great job, this was beautiful. At this point you have learned a lot of things. This is amazing. Great job on completing the seventh part of this project. In this particular task, we looked at list as a data structure. So this concludes the lessons on data structure. We've seen matrices, we've seen vectors as a data structure, we've seen data frame as a data structure. And in addition, we've seen how to access the different rows or columns or elements of this different data structure. And in this particular task, we saw how to access different objects of a list. And one thing is that a list brings together a variety of objects, be it vectors, matrices, and whatever. And great job. In the next task, we'll learn how to install packages in R, because most times we want to perform some data analysis and you have to have some packages installed. You will see how to use a particular function and using the RStudio console. And in addition, we'll see how to set the right working directory for our work. I must commend you at this point in this project. Beautiful. If you are ready, I think you should join me in the next task. Okay, welcome back. In this task, you'll learn how to install packages in R using the RStudio console and using the install.packages function. In addition, you'll learn how to set the right working directory in R. R packages are a collection of R functions and datasets. There are some standard ones that come with R. So if I come over to this down panel here and come to packages here, I would see some packages that have been installed already in our default in R, but sometimes we want to do some more complex analysis or something. For example, in the last task in this project, we'll be importing some data sets that will require some packages. So the first package we want to install is the read R package to read different data sets like the Excel or the CSV data sets in R. So to do that, you will just install dot packages. Immediately tells you that, so you can see, then you put the package name in quotes. So the package you want to install is read R, so I put read R and control enter. At that point it tells you installing packages, so I'll pause, and when it is finished installing we'll continue. Great, I guess that took a couple of minutes, so we can see that the read R package has been installed. But that is just the first part. When we install a package, we want to read it into the R section. To do that, we simply say library, then you say the name of the package, read R. At this point, you see that the read R package is now installed. So if you go down here and look for read R, you'll notice that it is on check when you check your read R, all right? So that is that. Good. Again, I want to install a package read XL, but I don't want to use, that's why I commented this out. I don't want to use installer packages. I want to use the RStudio console. So to do that, I'll come over here. You see this install button. I'll click on install. and it opens up this. In this place, I will type the package I want to install, read XL, and it shows me the option. I can just click on that, read Excel, and click on install. And the same way it starts to install. So I'll pause now and continue later on. I guess that was much faster than the read R. So you can see it has successfully installed. We need to read it into the R section. So we'll do library XL. So that's I'll run this now. So with this, the read XL is already installed and then it has been read to the R section. Lastly, it is important to set the right working directory for your work. In this our case, we were in the right working directly, so there was no issue. But subsequently, when you work with R, you need to set the right working directory where your files and everything you need. Because if you are trying to import a data set, for example, and you're not in the right working directory, an error will come up. There are two ways to do this. Is either you do set WD, that is to set the working directory, and you go on to copy the directory of the where the folder exists. So I will do that now. So open up this, go on to my desktop. This is exactly, this is the right directory I want. So I'm just going to copy the address here. Just going to copy the address. So on this address, I'm going to just right click and copy. Afterwards, I'll come to my RStudio and type set WD. That's to set the working directory. Open brackets. Then I have my quotes. In the quotes, I'm going to right click again and paste. All right, inside of the quotes. And paste it. And so this works correctly. One more thing is that this backslash wouldn't work in R, so you have to change it to forward slash. So I'll change it of this backslash to forward slash. All right, so I have it in quotes and all that in forward slash. So I just have Control Enter. And this sets the right working directory. So I can actually get the working directory by doing get working directory, and it will tell me the current working directory I am on. So with this get working directory, I can get the current working directory that I am on, and that tells me that I am on this particular working directory. That looks to be a very difficult way to set working directory. Another way to do that is to use the R console, RStudio console. You come over to section, and from section you see the set working directory. I think this is a simpler way to do that. Then set working directory, you come down to choose directory and you navigate to where you want. Currently I'm in the right directory, so I if I have another directory I was trying to go to, say somewhere else where I have want to work with another script or probably some other data set, then I will just try and navigate to that point. But since I'm in the right directory, I just click on open and that suffice. Great. So at this point in this project, you have learned a lot. This is amazing. In this particular task, we saw how to great job on completing the eighth part of this project. In this task, we learned how to install packages in R using the install.packages function and also using the RStudio console. In addition, we learned how to set the right working directory using setwd and getting the right working directory using getwd. Great. In the next task, we'll conclude this amazing project and interesting project by looking at how to import different data sets in R. Okay, welcome back. In this task, you'll learn how to import different data sets into R. Many times, data are already available in different formats and are ready to be imported into R. Data like .txt, .csv, .excel, .spss, .sas. R accepts these different data formats. In this task, we'll learn how to import files of the following format: .txt for space separated and comma separated, .csv, and .xlsx, that's for Excel. I've also included a link in the description of this particular task to access different other types of ways to import different types of data sets, like different formats. So I have here a particular file data set that is space separated. Let me open that with Notepad. That is space separated, and I want to import that particular file. So to do that, I can just name it a variable, say txt data. So the function I'll use is read.table, and here we can see that the read.table takes the file, takes the header, whether false or true. Either false or true means do you want to have the header or not separated. In this case, because the space separated, I wouldn't have a comma, so I wouldn't have a separated I won't add this. So I think that is all. Inside that place, I'll have my quotes, data sets .txt, then header equals to true. So we can see that if you do not put this .txt, that's the format of the data, it will not run properly. Read.table, so that is good. We can easily check the class of the txt data, and it shows that it's a data frame. Now, want to view, want to see the data. One way to do that is you can always print it, or you can just come over here to where txt data and double click on it. When you double click on it, it opens up, and so you can see it at inside, as against when I go here and type txt data. In this case, this prints on the console, but here we can actually see it, and in fact still export it. All right, so that is one way to do it. Another way to do it is to do view, capital letter VIEW, txt data, and if you do this, then it will open up also on this, and you can actually see that it has 14 observations. Very good. The next thing is want to have a peek at the data set, like want to just see the first 5 rows or the last rows, in case there are like thousands or millions of rows of a particular data set. And to do that, you use head, the head function. Head, then you put your data set there, the txt data, and this shows like the first 6 rows, so you can have a peek at your data set. If you want just 5 rows, you just come beside it and put a comma 5, and so that will just return just the first 5 rows of the data set, like this. Now what if I want just like the last 2 rows? You use what we call a tail function. So you say tail, you want to check txt data, then you want to check the last 2 rows. So with this, you check the last, it will give you the row 13 and the 14. Good. Now let's check the structure of the data. That is so easy. We've seen that before. str txt data. So this shows us the structure, that there is a variable, sales, country, quota. That is, so we can see the different data types of our variables or our features. Now we want to check the summary, like the summary. Let's check the summary of the data. We've seen that before. So the summary just gives like a statistical analysis. So this is the categorical variables. We can see the count. Then for the numeric variable, we can see the mean, the first quarter, the median, the mean, the third quarter, and the max. So that's what summary does for the numeric, and then for the categorical variable. Now this is a very important thing to note, where you have, for example, the sales data, the sales feature that we had earlier was a factor of 2 level, if you look at it clearly. Now, if we want to change it to, say, a character, how do we do that? I'll call my txt data with the $sign that we've seen before. So I'll pick the sales feature, then I want to assign it to a character now. So I'll say ax.character. So that means I want to change this to a character. So what do I want to change to a character? I want to change the sales feature to a character. If I do this now, you'll see that it will run clearly, and if we check the structure again, the structure will change to character. Running the structure again, you see. Now you can see the sales is not a character. Also, if I want to change it back to my factor, I'll just have the same thing, but instead of as.character, I'll ask as.factor. Now let's run this and run the structure again. We'll see that if we go on to run the structure again, now the structure shows that it's now a factor. Good. Now let's try to import a data set, a txt file that is a comma separated. I also have that file here, orange. Let me open that. And you can see that it's a comma separated. It talks about an orange tree with the different edges and circumference. Let's see how we can import this. The same way applies like we've seen. The only thing I'll add is SEP, that's to show that it is comma separated like this. So comma separated. If I run this now, that works just fine. So we can also check like we can view it. We can view it. Capital letter V, be careful of that. And that shows us here the different data sets for orange. Now let's go on to check the summary. That is what we've seen. And this shows the different summary, like the mean of each of the variable. Let's check the structure. We've seen that before. So we can see that they are all integers, are numeric. Now I want you to pause my video and try to change the tree feature, which is an integer or a numeric value, to a factor. Yes, try that now. And so I've changed this to a factor. I just used as.factor. We'll go on to check the structure again. You'll see that 3 is now a factor. So you can play around that again. Next is we want to import a CSV file, which we'll be using mostly in R. First, I need to import this library because we'll be using it a lot here. I have a data set diabetes that I have on in the folder. So I can just say diabetes read.csv. So the data set is diabetes.csv. Okay, so let's run this. So that has imported, so we can actually check the data type by using class diabetes. That's the data frame. So I want you to do this yourself. I want you to retrieve the first 5 rows, check the number of rows and number of columns, check the data structure, check the summary. Or you can pause my video to try this out. So this is it. You can run it, check the class, the number of rows, number of columns, the structure, and the summary. Lastly, let us import an Excel file. All right. Okay. So I have a file that is dataset.xlsx. So let's try to import that. Let me give it a name like exdata, and let's say to do that you do read_excel. So to just put the data name, that's dataset.x, that is xs. So let's run this now. Okay, good. Or could not find this function. We need to import the library. Let's import the library read xl. So we've imported the library now. So I think now it should work fine. And yes, it has imported. This is just a warning message and no issue really. Let us just try to check the class of the data, class of exdata. Now you notice that this is in different data kind of data format. Now let us try to just change it to proper data frame, and I can do that using the xdata. So I want to change it to a data frame as .data.frame, and that's we change it to a proper data format. So when we check the class now, we can now see that it's the data.frame as expected. Great work you've got there. Beautiful. That was amazing, right? Great job on completing the ninth part of this project. This brings us to the end of our hands-on project working with R. In this task, we learned how to import different datasets into R. I believe you've learned a lot in this project. What is the next step? Start making use of the ideas you've gleaned from this project in real life. I suggest and strongly recommend that you should install R and RStudio on your device. It is open source. Then you can do more exploration and build upon what we've learned from this project. Note, this is the first project in a series of learning R for data analysis. Stay in touch for the next project in this series. Thank you for learning.